Good morning, children. Today we will discuss about the identities in exercise 18. Right here. Exercise 18. I would like to tell you that you have not to all the questions in this exercise after modification of the syllabus. Only you have to do the questions based on the identities. So you mark it from question number 8 up to 26. Only this is your syllabus which you have to study. And rest of the questions are related to the elimination method and the angle properties which you have not do it. So now you come into the identities. From question number 8 up to 26, only you have to use the formula of identities. So first of all, we will discuss about some formulas which will be used in the identity. There is only application of the formulas of identities from question number 8 up to 26. So we will divide the formulas first of all mainly into two parts. Part 1, look at here, sine square number 1, sine square theta plus cos square theta, that is equal to 1. This is the relation between sine and cos of the trigonometrical ratios, because sine, cos, tan, cosec, sec, cot, these are known as trigonometrical ratios which you have been studying in standard 9 also. Sine equal to p by h, cos equal to p by h. If we use p by sine square equal to p by h, theta is the angle, it may be beta, alpha, x, anything, doesn't matter. This is the acute angle theta. So look at here how this is equal to 1. P square by h square, this is the value of sine square, plus cos square, b square by h square, simplify it and use Pythagoras theorem, that is equal to h square, p square plus b square, and p square plus b square, that is equal to h square divided by h square, so that is equal to 1. Number 1 thing. Second, in the identities, you will not use anywhere PBH. I have explained how sine square theta plus cos square theta equal to 1. Look at here. Sine square equal to p square by h square, b square by h square, and after big simplification, this is equal to 1. So directly for the place of sine square theta plus cos square theta, if it is required in the question, then we will use that is equal to 1. If we derive this relation, we will get two more formulas. Number 1, if we make sine square theta as a subject, that is equal to 1 minus cos square theta. Look at here, for the place of sine square theta, if it is required in the question, then we can write down 1 minus cos square theta. Or for the place of 1 minus cos square theta, we can write down sine square theta according to the requirement or demand of the question. Next is the cos square theta as a subject. Second, cos square theta, that is equal to 1 minus sine square theta. So we can write down for the place of 1 minus sine square theta equal to cos square theta, or for the place of cos square theta we can write down 1 minus sine square theta. Similarly, second, sec square theta minus tan square theta, that is also equal to 1, using the ratios of sec and tan and Pythagoras theorem, like sin square theta plus cos square theta, this is also equal to 1. This is the formula of identities. The trigonometrical ratios between sec and tan are related in this way. Sec square theta minus tan square theta equal to 1. 1 by 1 you make sec square theta as a subject, you will get another result, another formula, like first or sec square theta equal to 1 plus tan square theta, or second, sec square theta minus 1, that is equal to tan square theta. Remember, these are the formulas which will be applied to prove the questions in the identities from question number 8 up to 26. Third, cosec square theta minus cot square theta, that is also equal to 1. Again, what will you do? Once you make cosec square theta as a subject, you will get that is equal to 1 plus cot square theta. Next you make cot square theta as a subject, you will get cosec square theta minus 1 equal to cot square theta. So these are the relation or formula which you will have to apply in the questions directly to prove the questions. In the identities, almost all the questions you have to prove it. Second part of the identities, like look at here, sin theta equal to 1 by cosec theta. You have already been studied about the value of sin theta and the value of 1 by cosec theta, because sin and cosec are inversely related. So sin theta can be given 1 by cosec theta, or sin theta into cosec theta, that is equal to also 1. This is also called second part, formulas of identities. Similarly, sec theta cos theta into sec theta, that is equal to also 1, and tan theta number 1, number 2 and number 3, tan theta into cot theta, that is also equal to 1. Deriving either for the place of cos theta, we can write down 1 by sec theta, or for the place of sec theta, we can write down 1 by cos theta. This is the second part. So directly these formulas will be applied to prove the questions in the identity. Remember it. Now we will discuss about some question, and you look at the question, how we will proceed into the particular question to prove the questions. So you look at here. Children, question number 10, second part. You write down the question and look at how these formulas or the relations are applied to prove the question. Question number 10. Prove that prove that 1 plus tan square by 1 plus second part of this question. 1 plus tan square by 1 plus tan square a by 1 plus sec a. 1 plus sec a, that is equal to sec a. Look at here, children. You have to split either of the sides, either LHS, then you should get RHS, or RHS, then you should get LHS. You will not split together sides at a time. This is not the method in the identities. So you have to split either of the side to prove the another side. So you split the LHS. This is your LHS. And after splitting the LHS, using the formulas of identities, you should get RHS. In some particular questions, rarely, because identities are studied in 12th class also, same question, some length of the question will be bigger, longer, but the chapter is same. So sometimes what will be happen, either such type of questions will be given or not, doesn't matter. If you are splitting the LHS, you will not get the value of RHS in the particular question. Then split the LHS, find out the solution. Again, now you split the RHS and find out the result. And lastly, LHS and RHS should be result of the LHS and result of the RHS should be equal. Then question will be proved. So LHS is split, better you split the LHS using the formula of identity. We will split the LHS. 1 plus tan square A can be written sec square A minus 1. Okay. Just I have written the formulas of identities. Relation between sec and tan. Sec square A minus tan square equal to 1. Therefore, tan square A equal to sec square A minus 1. So, for the place of tan square A, we will write sec square A minus 1. Now, we are using the formula of identity. Writing sec square A minus 1 for the place of tan square A. And denominator is write down 1 plus sec A. You look at the numerator here. It is in the form of a square minus b square. That is equal to 1 plus the sec square A minus 1 can be written sec A plus 1 into sec A minus 1. So for the place of sec square A minus 1, you write down sec A plus 1 into sec A minus 1 and divided by 1 plus sec A. Right? Use the formula of identities, simplify it using the method of simplification, general method of simplification, and move in the forward direction, and finally you will get the RHS. So 1 plus sec A and this 1 plus sec A will be cancelled. That is equal to 1 plus sec A minus 1 is the remaining terms. Minus 1 plus 1 will be cancelled and finally you will get sec A. This is your RHS. Don't write down the answer. You will write down either quote or RHS. Look at it. RHS. This is your question. Look at another type of the question in the same exercise. Question number 15. First part, prove that. आप देखते जाइए, इसमें सिर्फ एप्लीकेशन है आइडेंटिटीज का, सिंप्लीफिकेशन है और आपको आरएचएस आएगा। उस तरह से आपको बनाना है। इन क्वेश्चन नंबर 15, प्रूव दैट tan स्क्वायर थीटा माइनस sin स्क्वायर थीटा, tan स्क्वायर थीटा minus sin square theta, that is equal to tan square theta into sin square theta. Tan square theta into sin square theta. Look at children, what will we do? Using the formulas of identities, we will simplify the LHS to get RHS. LHS. For the place of tan square theta, we will write sin square theta by cos square theta, because tan theta equal to sin theta by cos square theta. This is why tan square theta equal to sin square theta by cos square theta minus sin square theta. Now reunite the terms taking the LCM using the general process of simplification. Cos square theta, now sin square theta, LCM will be cos square theta minus cos square theta into sin square theta. In the numerator, we will take common sin square theta as a common, that is equal to sin square theta, and the bracket will be 1 minus cos square theta, 1 minus cos square theta divided by cos square theta. Look at here. Now we will use the formula of identity. 1 minus cos square theta we can write down, that is equal to sin square theta. Sin square theta into sin square theta, that is equal to sin square theta into sin square theta divided by cos square theta, because 1 minus cos square theta it will be equal to sin square theta. So sin square theta into sin square theta divided by cos square theta. Whatever we have to get like as RHS, after splitting the LHS in the same directive we will move and we will simplify it. So you write down together this sin square theta by cos square theta to obtain tan square theta, because in the RHS we will have to go tan square theta into sin square theta. This is what RHS which we have to prove. So sin square theta, this term will be written that is equal to sin square theta by cos square theta to obtain tan square theta into this sin square theta. This sin square theta plus cos square theta that is equal to tan square theta into sin square theta. RHS, this is your RHS which we have to prove it. Then what will you do? You always, in almost all the questions, you have to apply the formulas of identities according to the requirement. Whatever we have to prove the RHS, then we will simplify it and then we will then we will prove it. So you will do the practice, and whatever you have in the practice problems, while you are going to do the practice, whatever you having the problems, you will raise your problem and then we will discuss about your problem in the next class.